This is what I will have at the end of this episode. As you saw in the intro, I have the watch back from Italy. And in this episode, the first thing I'm going to do is focus on making the case back, which is held on by these screws. Once I've done that, then I'm going to focus on finishing the watch, getting rid of burrs, sanding, polishing, that type of thing. I'm not a watchmaker. I'm new to all of this, so a lot of things I'm learning by trial and error, which means, I'm not yet to the point where I'm doing a great job. But that's okay because this is a prototype. And the purpose of the prototype is twofold. One is to be able to show it to various people, which is what happened in New York and Germany. The other purpose is to get the experience with building the first set of watches to figure out what we want to change for the production version. So I will have future videos where I focus on the journey forward and into production. But for now, let's head to the machine, right there, and start to make the fixture for the case back and then work all the way up till we have an assembled watch. I always start with the 2-inch tri-fly from Shrum Solutions to deck off the top. The idea is that this fixture will hold the back of the watch firmly in place while I mill the inside diameter. So here I'm roughing out the pocket to hold the back with a 3/8 inch diameter end mill. I'm spotting 3 locations here. The first one that you saw at spot is the back left, which is X0, Y0. So I put the fixture back in with the correct orientation. Once the spotting is done, then it comes back and I peck drill the 2 holes for these screws. And then a chamfer on the 2 screw holes to get the tap started. The sides of the fixture are sloped to match the sides of the back of the watch, and so I'm using a ball end mill, 1/8 inch diameter in size, to ensure that those are nice and smooth and the correct slope. This is a fixture I made for the first operation for the back of the watch. I'm going to mill the inside diameter first so that I can put it on an inside diameter clamp, and then I'll be able to mill this side and this side on the same fixture. So this fixture has some slopes, as you can see here, that match the slope on the outside. And so I just push this in here, and then I'll hold it down like that. And then snug these screws down and then tighten them up. And this holds it plenty firmly enough so that I can mill the inside diameter. Okay. I'm milling the inside diameter at full depth using a 1/4 inch 4-flute end mill and multiple passes. I will probably do some experimenting with how much I can cut for production, but for now I'm taking fairly light passes. And then once I'm done with that, I use the chamfer mill to put a 0.002 inch or 2/1000 of an inch chamfer just to break the edge. This next inside diameter clamp is used to hold onto it this way as well as this way. And so the reason it's not very far down is because on this side we're going to be milling features down closer to the top of the fixture. Anyway, right now I'm going to put it in this way, make sure it's seated well, and then tighten it up. And it's all set to go. This is taking 1 millimeter off the thickness of the part, and you can see that from the large burr that it's kicking up, that the end mill either has a chipped tooth or is otherwise dull. I've used this for, I think, 7 or 8 watch cases, so I need to figure out what the right recipe is to have the end mill last longer. And then I use the chamfer mill to get rid of that burr, and then blow it away before the next operation. The back has a slot for a 0.7 millimeter diameter O-ring. I'm using a 1/32 inch end mill, sorry, to mix units there, to cut the slot in multiple passes. Okay, that side is done. So I'm going to take it out, and I can see a little bit of a burr on there, so I'm going to just put it on a piece of sandpaper briefly and then flip it over. You can clearly see that the burr is even worse, which means the end mill definitely is at the end of its life. And I had to pull the burr off. I probably should be using gloves here, but I was being careful, and the burr was not too sharp on my hands. And so then I came around with the 1/16 inch diameter end mill to cut the shelf for the crystal that's going to go on the back. And that took care of the leftover burr from the previous operation. The back is attached to the case with some really small socket cap head screws. I think they're 1.4 millimeter threads. So this is cutting the pockets for the screw heads. This is using the chamfer tool to remove the burr on the edge. It's basically adding a 2/1000 of an inch chamfer, which is barely visible, but makes the edge nice and smooth. Then it's spotting the location for each of the holes for the screws, which will be drilled next with, I believe it's a 1.4 millimeter drill. And for production, I'm going to want to reduce the height where it's going slowly like this so that it can cut all of these a lot faster. The same thing applies here when I optimize the tool paths for production. I'm going to want to reduce the retract height so it spends less of its time just moving down to the start of the hole. This is where we get to the fun part, but that's probably hard to tell watching this video. This is running at 30,000 RPM with an engraving cutter that has a 3/1000 inch diameter tip, which is really, really tiny. It's a 60-degree angle on it, and this is what I'm using to engrave all of the text that is around the circle on the case back. The first thing I need to do is clean some burrs off. You can see there are some burrs along there. And so I have some stones that are for injection molds that I'm going to give a try. And so let's see, these come in all sorts of grits, and I think I'll start with 320 grit. So this is one of the stones here, and let's see how that goes. So I'll just okay, I think I'm going to want to start with a hair grit. So I have a 100 grit stone here, and let's see how that does. So I'm going to put on some magnification and get really close with my eyes so I can see what I'm doing. And I don't know if you can see it. Yeah, you can see it. What I'm able to do is to just basically separate those burrs. And that's really nicely cleaning up that edge. I'm going to keep doing this. Okay, so I want to polish it a little bit more. I'm going to practice on the back where you're not going to see it to get a feel for how much I need to sand it. And then once I have a feel for the back, then I'll do the front. Okay, that's getting there. And I'm just putting WD-40 on here, and then I can blot away the dirt pretty easily. And so that gives me some fresh sandpaper again. And that's turning into a nice finish. So now, if I go back and forth like this, it should give me a brushed finish. So let's see what it looks like when I dry it off. And I need to make sure I clock it, so I'm going to use the analog time there. Okay, getting there. Yeah, I'm certainly not an expert on finishing. Okay, line it up again. Well, it's becoming smoother, but I wouldn't call it brushed just yet. I guess I'll keep doing that. Okay. Yep, it's definitely getting there. It's not going to be an award-winning finish, but this is a prototype. And I am not a watchmaker. Yeah, it's coming out nicely. Anyway, that's the back side. You'll never see it. So now I'm going to try the visible side of the back. And I'm going to try something different here, which is first I'm going to do a quick sanding. The lettering should be 3/1000 of an inch deep. And that's actually pretty good. It's giving it kind of a satiny finish and making the lettering a little bit easier to see. Okay, I like that. It's not shiny anymore. Now the other thing is there are some burrs down in there. And to get rid of those burrs, I have this, I'm not sure what tool it is, but it's a kind of deburring tool. And so what I'm doing is, I don't know if you can see it very well, but I'm basically taking and just going along those edges to get rid of any little burrs that are down there. And for production, what I would want to do is have a 3D toolpath that does the deburring in the machine, because that's a lot easier and Well, setting it up isn't easy, but once it's set up, running it is a lot easier than doing this by hand. Okay, now I'm starting to get the hang of it. Usually get the hang of it on the last or second to the last one, which is what just happened there. Okay, so I'm going to want to clean this up before I assemble it, but I'd say that part's done. And now we can move on to the front. And so I'm going to want to sand this surface here. It would be nice to polish this surface here. And I do have some tools I can use for that, so I'm going to give those a try, but I'm going to start with this surface here to get rid of the tooling marks. And that should give you an idea of how shallow the tooling marks are. They're almost gone after just a few passes. Okay, I see some tooling marks there, so I'll do it a few more times. Okay, I like that finish. Then I'm going to try sanding the back, and I'll need a small piece of sandpaper for that and have to do it by hand. So I'll take and put some WD-40 on that. And again, I probably don't need to do this for the prototype because it's going to be covered by the back. Let's see how far that's taken us. I can still see the tooling marks, but it's definitely better. And I don't know what grit this is. Let me have a look. This is 600 grit. And this right here is 220, so in theory, I should be able to finish this with the red sandpaper afterwards and have a brushed, well actually this should give me a pretty nice finish. Yeah, it's getting there. Okay, now I know I'm not a watchmaker. All right, I think I'm going to start assembling it. It will be, I'm going to end up gluing the crystals in place, so it'll be a semi-permanent installation, but as I said, it's a prototype, so that's okay. This will be my first time seeing the whole thing together. Before I can put this into the case, I have to remove the stem, and so there's a little button down there that allows me to remove the stem. With the stem removed, I can now loosen this and then carefully place this into the case. And I'll put this is just a temporary stem. It's not the final stem, but I'll put this stem back in because that'll help position this so that when I put in the case clamps, this has the correct orientation. So now I need to put in the case clamps. And I unfortunately sent the correct case clamps off to Italy. I meant to keep them, so I'm going to have to use a slightly different version. And then the movement, it does come with some case clamps, but those are too short. It also comes with the screws that I need for the case clamp, so I'll pull all of that out. Okay, here's one of the case clamps, and this operation is a little tricky, but what I want to do is try to push it into the slot that I milled into the case. There we go. So now that's in there, and then the next trick is to put the screw in place. And the screws are really, really tiny. They are, I believe, n.8 millimeters. And so what I'm trying to do is get it on here so that I can drop it in place. Now I've done this before with the camera, without the camera, and did not have this many problems. Let's see, what I'm going to do is put this plastic underneath here so that it should help, give me a little bit of gravity assist to keep this balance wheel from getting in the way. Okay, and then what I'm going to try to do is get the screw to drop into the hole. I'm certainly impressed with watchmakers. There we go. And now, okay, I don't want to tighten this down, but now I've got that case clamp in place. And the difference between this case clamp and the ones that we spec'd is that this is not as wide. The slot is, I think, about 2.2 or so millimeters wide, and that's the width that we wanted, and these are definitely narrower. Okay, so now I'm going to try to put that case clamp into place. First thing I want to do is, there we go, turn it over so that I have the bent end up. Let's see if I can do a better job on this one. Okay. And now for the fun part, the screw. Ha! Second time is the charm, right? Now, because of the bend with the case clamps, let me put this into view. Because of the bend with the case clamps, when I tighten down on the case clamp, it pushes the mechanism down that way against the shelf here. And so now the movement is constrained, and it's not going to move back and forth, so it's firmly in place. I have a crystal here that's a little bit smaller than the diameter of this opening. The idea is that the glass will be held in place with a gasket, and we did get these gaskets that said that they're, I think this one says 27.5, but you can see it's too large to fit into the opening. So because we don't have the right diameter gasket, I have some smaller crystals, and then I have this glue that I'm going to try. So what I'll do is put a little bit of a bead of glue all the way around. I don't want to use too much. Okay, and it's just coming out without me doing anything, so I'm going to try holding it this way. And then spread it like so. And hope it turns out okay. And this is my very first time doing any type of watch work. Okay. Probably not perfect, but that'll do nicely. Okay, this next part is easy, which is to put the back on place. And these screws are much bigger. They're M1.4 millimeter screws with much larger heads. I forgot to mention that there's an O-ring that is supposed to go in here. And again, we don't have the correct size O-ring, so I'm just assembling it without the O-ring. We're going to need to go back and forth a couple times, try different sizes, and figure out the exact correct size for the O-ring. Okay, now I can turn it over, and now we get to the fun part, which is to put the hands in place. So I am going to start with the minute and hour hand. Okay, let me start with the hour hand. So there is a tool for pushing that into place, which I think is this one right here. Okay, that's in place. So it seems like the second hand that I have is not quite right because it's slipping on there. I have the glass on here now. If I move my hand, you can see I can get rid of the reflection from the overhead lights. After doing some research, I discovered that the reason the second hand was not staying on is because the second hands that I have a 0.25 millimeter inside diameter, and this movement requires 0.17 millimeter. So that's why they were loose. Given that I need to get this sent out today for a show that starts next week at the time that I'm recording it, not when you're watching it, I'm just going to leave it like it is. So I glued the glass in with just 3 different places, and it's ready to head off to Thomas in New York. Now if we look at the back, I'm really happy how this turned out. The engraving is really nice. This is using the 3/1000 of an inch diameter tipped engraving tool, cut 3/1000 of an inch deep. One thing I discovered is that it didn't look this good when the back had all the tooling marks on it, but when I sanded the back on some, I think 400 grit sanding paper and made it more of a satin finish, the lettering really pops, and so it's a lot easier to read now. So I'm filming this several weeks, I think about 3 weeks after a lot of the footage in the video, and that means I have the watch back from Italy. The watch is not exactly what I would like. For example, the hour and the minute hand are silver, and on this particular version it's a skeleton movement, so you can see things moving, etc. There's no dial on it, and so without a dial, the silver hands make it hard to read the time because they blend in too well. The other thing is I like a second hand, and we did not have the correct second hands to fit, as you saw. So these are the types of things that are different between a prototype watch and a production watch. The prototype watch allowed us to figure out the things that we need to do next. And so we're putting together all of the list of things we need to do next. And I'll have videos in the future taking you through the process of going from where we are today with a prototype to the point where we're ready for production. There are also going to be 2 other designs that I'm going to be working on as well. This is going to be a Kickstarter, I believe, in April is what I heard. Not really sure of the timing. This is not my project this is done by Analog Labs in Italy. And I'll put a link to their website below. I'm also going to do some more detailed videos, like someone has requested that I do some videos on the feeds and speeds that I used for stainless steel. So I'll do a video getting into the detail of how I set that up. I am also going to do a more detailed video on the 4th axis in the future, and probably other videos as I figure out what I should focus on. I hope you enjoyed this episode. Please help me grow the channel. You can do that by subscribing, giving me a thumbs up, and commenting below. Those are all things that help the algorithms bring new people to my channel. Thanks for watching, and I'll see you next time.